Okay, so here we've got yet another polynomial, and unfortunately this time it is not factored for us. So we can answer some of the easy questions right away. What's the degree? Well, 4, yeah. What's the domain? All real numbers, same as always, negative infinity to positive infinity. What's the long run behavior? Well, we know because it's an even power, we know it's going to be something like that, right? And it's not been reflected. So we're going to say as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to positive infinity. Both ends are going up, so we'll go ahead and draw that. All right, do we know the zeros? Well, not straight up. However, we can think of this as it's quadratic in terms of x squared. So we could say let's let u equal x squared. Then this is called a u substitution, and if you go further in math, you're going to see it over and over and over and over again, including a couple of times more in this class. So deal with it, right? You need to get used to it. Okay, so if we rewrite our function in terms of u instead of x, we'd say, okay, x to the 4th, well, that's u squared. 10x squared is going to be 10u. 9's not going to change. And then we look at that and we say, oh, that's a quadratic, and I think I can factor that, right? U minus 9, u minus 1. And at this point we say, okay, great, well, I could solve for u, but that doesn't help me because I need to solve for x. So let's change it back to f of x. So we know x squared minus 9, x squared minus 1. So we've gotten it factored. And honestly, if you recognize the pattern and you can go straight to x squared minus 9 times x squared minus 1, that is wonderful. Go do that, okay? So we're looking at this and we're going to say, okay, I'm going to factor that, x minus 3, right? X squared minus 9 is the difference of perfect squares. So x minus 3, x plus 3. And x squared minus 1, same story, x minus 1, x plus 1. So now we know what all the zeros are, right? We know the zeros are 3, negative 3, 1, and negative 1. So negative 3, negative 1, 1, 3. And how many turning points do we have? Well, the max number is going to be 3. And in this case, since we have 4 zeros, we're going to have 3 turning points. Each one of these is multiplicity 1, so this actually, oops, can't get it, actually becomes a very straightforward W, and the only thing that's off about this, and it is symmetric, I just can't draw symmetric, the only thing off about this is going to be the scale, right? Because honestly, our y-intercept is going to be 9, and I didn't draw it like that. So there we go. So we could reverse the process. We'll go ahead and throw that in here. Yeah, find a polynomial that has degree 5, has a root of multiplicity 2 and x equals 1, has a root of multiplicity 3 and x equals negative 2, and has a y-intercept of negative 3. Okay, so first question is, do we have all of our roots accounted for here? And if we have a multiplicity 2 for one root and a multiplicity 3, that adds up to 5 roots, right? So yes, we have all of our roots accounted for. So we can start off by saying, okay, a root of 1, that would be x minus 1, multiplicity 2, all right? And then we have a root of negative 2, so x minus negative 2, multiplicity 3. Okay, so we have checked off degree 5, the root of multiplicity 2, the root of multiplicity 3. What we haven't figured out if it matches is, does it have a y-intercept of negative 3? So here's our first question. If I plug in 0 right now, do I get out negative 3? I would get negative 1 squared, that's 1, times 2 cubed, 8. So that's now not working. So, but here's the thing. that we haven't really talked explicitly about is that, well, any scalar multiple of this factored form will have the same zeros, right? This is that idea of vertical stretch, right? The vertical stretch did not change the x-intercepts. A horizontal stretch did, okay? So vertical stretch, just multiplying these factored forms by a constant, will not change our intercepts, our x-intercepts. So let's plug and chug now and solve for a. So we know y is -3. We don't know what a is. We've got 0 minus 1. We've got 0 plus 2 cubed. Okay, so we've got -3 equals a times 1 times 8. And we can solve for a, -3 over 8. And therefore, we have our answer, right? We have y equals -3/8, x minus 1 squared, x plus 2 cubed. So you definitely want to be able to do this type of question because this is a very easy one for me to ask on the test. Oops. Okay, so this is a good break point, and we'll kind of take the opposite approach on the next one.